Okay, we're doing a little bit of review for the vectors test tomorrow, and we started with that point, and then I said we were going to move from that point 6 feet to the right, up 1, and back 2. And I said, write me a vector equation for that. All right, let's see. I'm going to ask a random person. Randomly, I have chosen row 5, the last person. 3, 4, 5. There we go. What you got? Yep. So start with an x, y, z. Yup. Yup. Raise your hand if you had the same thing. All right, good. Now, that vector equation can generate lots of points. Notice a common mistake here is people think that's the first point and that's the second point. False. What is the second point? What is that yellow point's position? And then write me another point that's on this. So I'd like a set of 3 points that's on this, but I'm going to excuse you from the first one because obviously that's the first point that's on it. So give me the next one and the next one. What are the next 2 points that you'd come to that are whole numbers? Yes, sir. Yes? Can we go beyond the yellow point? Absolutely. That's a good question. So the question was, if I go from the pink point to the yellow point, we know what the magnitude of that is. But if we want to go from the yellow point to some point further down the road, then we're doing 2 of the magnitude to get there. Does that make sense? So we're not losing the magnitude. We just took 2 times magnitude to get to the next spot. Yes?
Magnitude then be said to be multiplied by.
Well, this alone is not its magnitude, so no. But this will give me its magnitude, and that's one of the questions I was going to ask next. But let's finish the one that I just said. Can you give me 2 points there that you have, lady in the front row? 11, 2, negative 3. Raise your hand if you had the same thing. Okay, good. And what's the next one?
17, 3, and
All right. So that's some R2 level stuff. You feeling comfortable so far? All this seems pretty easy, I hope. Okay, good. So now let's say that I said, what is the magnitude of this vector? Figure it out. So the magnitude is basically how long this vector is. Now, if I was going to go from the pink to the yellow, then I could go the long way, which is I'd go 6 to the right, then I'd go up 1, then I'd go back 1, and that adds up to 6, 7, 8 feet. And that's about how far apart they are. They're about 8 feet apart if you were to go the long way, but they're actually closer than that, because most of us would only talk about the distance between them, the shortcut, like going straight from the pink one to the yellow one, which means I'd take, it's like a hypotenuse. So I go square root of 6 squared, 36, plus 1 squared, which is 1, plus 1 squared, which is 1, square root of 38. Raise your hand if you had that one right. Would you agree that square root of 38 is just a little bigger than the square root of 36? And therefore, it's just a little over 6 feet long. Now, make this into a unit vector. Remember the symbol for that? Like if this was called vector V, then it would be V with the little hat. Very good. Write that for me. What's the unit vector for this guy? So many things we can do with just one vector. DH, start us off.
Well, okay,
Yeah.
one
1 over, what was it again? 60, 38, thank you. And all right, I'm going to write it this way, but you could have used a column vector. 6i, 1j, negative 1k, or just negative k. All right, so what would be different if I said, I want one that is going the same exact direction, but 50 feet long. This is how long? Exactly 1 unit long. In this case, feet is the unit, so it's a 1 unit long vector. And if I want it to be 50, I just have to times it by 50. There we go. All right, now I'm going to stretch your brain a little bit, kind of like we would on the test, where it might be slightly different than what I asked before. What if I want it to be 50 feet long, but I want it to start at over 1, up 2, towards your 3, like right about there. I want it to start at 1, 2, 3. Write the equation for that. This whole thing, that, notice, did we ever take into account the 5, 1, negative 2 in this? Do you see that represented anywhere in there? Nope. That's all about the direction and the magnitude. So the starting point just needs to go in front of that. So to make it an equation, I'm going to put x, y, z, and then the starting point of 1, 2, 3, plus all that, and the only thing it needs is a what? A lambda. Couldn't I put the lambda like right here? 50 lambda over root 38. Again, there's a lot of ways you could have written that with the lambda out in front of it, or actually probably could put the lambda at the very end here, I suppose. Don't usually do that, but. And then could you have written this in a column vector? Yeah, you could have said 6, 1, negative 1, just like the original one. So that's a lot like saying, write me an equation for one that's parallel to it. You remember how if you want ones that are parallel, they're going to have the same direction, like this and this are the same? Or what could also work instead of parallel? A multiple of it. Like in this case, just double it. What would you have? 12, 2, negative 2. Yeah, if we had a 12, 2, negative 2 vector instead, it's double it. It moves twice as far, but then its magnitude then is twice as long. And so anyway, that would stay parallel to the other one if we doubled all the numbers. But you don't have to do that. That's just an option. All right, then, go back to this original one. And would you please write me an equation for one that's perpendicular to this vector v. Write me an equation for any vector that will be perpendicular to this. I'll pause for a second while you give that a try. Okay, you had to have certain components, but you had a wild card on some of them. X, Y, Z, this starting point, don't care. Could have been anywhere. Didn't say where it had to be. All right, so I'm going to say 1, 2, 3 again. You could have said anything. Doesn't matter. To be parallel, I would have said 6, 1, negative 1. But to be perpendicular, your numbers have to work like this. Here's a way to do it. If I put negative 1 here, you get how I'm going to get negative 6 for the start of my dot product? The dot product is what this is all about. If they are perpendicular, dot product equals 0. So I got negative 6 so far. What am I going to do here to counteract it? I'm going to make that 6. Negative 6 and a positive 6 will equal 0. And I could have made it 3, and then I could have done another number down here and made it another 3, but mine so far adds up to 0. Does that make sense? So then I really don't want anything for this last one, so I'm going to put that. Did anybody have -160? Awesome, I know that one works. Give me another one that works, and I'll check it and see if it does. Mr. C. 128, I will double check you and show people. Oops, order matters. 128. So then this makes 6, this makes +2 makes 8, and then this one will make a -8. Nice, that one's definitely got a dot product of 0. All right, and that brings up, why do we want the dot product to be 0? There's a formula for that. Say it. Cosine of 90, because if its dot product is 0, then that means this dot product on this side is 0. And we want this to equal 0 then. So the cosine of 90 is 0. We know that it's setting up right. All right, just a reminder of the rest of this. It's the magnitude for the one and the magnitude of the other one multiplied. Remember that formula? All right, so then, would you please go back to these two? I know this is only one kid's vector, but would you please do that formula? And I'm just telling you ahead of time, the answer comes out to 90. Act like this is a problem where they say, what's the angle between these two vectors? The ones that I have on the board right here. Do the process that gets you the angle between them. Cosine of the angle equals dot product over magnitude, magnitude. And you would need a calculator on this test. Calculators are allowed, so you probably want to get one out at this point if you have one. I'll pause for a second while you do that. I'm ready. Mr. P, go ahead. Excellent, which came out to? Excellent. The dot product was 0, so we put that on top, and then? The magnitudes came out to 0 again? Oh, true, but just for kicks, what were the magnitudes? Square root of and square, or did you just say, well, I don't need to calculate them? Okay, fine. But somebody did. What are the two magnitudes? Yes. We need to know the process because on most problems, the answer isn't 0 for the dot product. Okay, so what were they? Awesome. Then that's equal to cosine of the angle. How do you solve a problem like that? Inverse cosine. Awesome. Inverse cosine of all that, and that's 0. So inverse cosine is 0, and it comes out to 90. All right. Just to make sure that you understand this, let's say that I change these numbers a smidge. Let's say this comes out to 1 on top. Would you please figure out what the angle would be now? In case you didn't catch that, I just changed the top number to a 1 and asked, if the problem had come out this way, make sure you know how to do this. What would the angle have been if the dot product was 1? Okay, and let's use the dice of destiny. Select a random student. We have 3, 3. Row 3. I've been picking on you a lot, but it's the dice, not my fault.
I got 1.5. I have 1, so 3.
But is that degrees or radians? Okay, so that's actually interesting. 1.55 was it? All right, and that's in radians. That's not a wrong answer. Just you'd have to clarify that it's in radians because I'm going to generally default to degrees. Who's got it in degrees? Yes, sir. 88.88, very special number. Extremely lucky in China. It's true. 8s. Do you guys know Chinese enough to know what 4 is like in Chinese? Death. Say the number 4, it sounds dramatically like the word death. So it's like, is that right? S and S. It's like, I know I'm saying the intonation wrong, but if you just say it slightly differently, one means death, one means 4. And so 4 is considered an unlucky number, and 8 Do you happen to know what 8 sounds like that makes it favorable? Like, so basically, like prosperity or longevity is this. And it sounds almost exactly the same, just slightly. Just say it's slightly different. Like Joe instead of Joe. So, okay. So here's the hardest kind. This is where we've got two vectors and we know that they cross, and we just don't know if they cross at the same time. So here's the question. I'm going to give you two vectors, and you tell me where would they cross, and will they be there at the same time? That's the question. All right. X, Y, Z equals 1, 0, negative 1 plus lambda 2, 1, 1. And X, Y, Z, I'll do this one in red. X, Y, Z 2, negative 1, negative 2 plus, I'm going to use T down here just to emphasize that we don't know that the times are the same. We could find that out later. If it turns out lambda and T both come out to like 7, then their times were the same. If lambda comes out to like 5 and T comes out to like negative 2, then their times were not the same. Okay, hint, you're going to start by putting it into parametric form. I'll pause while we work on that for a bit. Okay, I notice there's a few people that are not sure where to start. I'm going to help you out. I'm going to start by moving this stuff over just to free up some room on the board here. And I'm going to say 1 plus 2 lambda, 0 plus lambda, and negative 1 plus lambda. That was X, Y, and Z. But notice I'm not writing the X and the Y and the Z. The top one is X, but I'm going to, if I said equals X right here, I just have to erase it when I write the next equation. So I'm just going to remember that that's equal to X. And the middle one's equal to Y, and the third one's equal to Z. The next layer is, I'm going to move this over, just save some room. Hold that thought a second. I was trying to grab all this. Slide it over here. Now, I'm going to warn you. There's a certain way you do this where if you're sticking one equation into the other equation, it just makes a true statement. It doesn't actually tell you the other variable. So instead, go back to the other equation and stick it in there. I'll give you an example. All right, so do you get we need to set the x's and the y's and the z's all equal? Please verify for me that you guys got this far. Raise your hand if you got that far. You got the x's and the y's and the z's set equal. Okay, good. That's step one. Next step, just be observant. Which of these, the top one, the middle one, or the bottom one, is already easy to use? The middle one. It says lambda is negative 1 plus t. It's already solved for lambda. Sweet. If you stick that in the bottom one, you just get a true statement. It doesn't tell you what lambda, oh, I put it in the wrong spot. I put it in the wrong spot. Okay. Sorry about that. Lambda is, no, that's right. Lambda is this, so I stick this in for lambda. Okay. But it ends up just giving me a true statement. It doesn't tell me what t is. P could have been anything, and it would have worked. Does that mean this is failing? No. If it came out to a false statement, like when you simplify this one down, it comes out to negative 2 plus t equals negative 2 plus t. When I subtract t from both sides, I get -2 equals -2. It's a true statement. That means we're not failing here. It's working, but it didn't tell me what t was. So go stick it in the other one then. Maybe you got lucky and just automatically used the top two equations, but the top two equations will work. I stick this in for lambda right there. I can solve it and find out what t is. 1 plus 2 times -1 plus t equals 2 plus 3t. 1 plus -2 plus 2t equals 2 plus 3t. Solving a little bit more, this becomes -1. I'm going to add it to both sides. Now I'm going to subtract 2t from both sides. And I get 0 equals 3 plus t. Subtract 3 from both sides. -3 equals t. A little slow and clunky, but I got her done. And if t is -3, have I finished the problem? They're going to hit at time is -3. No. You got started, but you didn't actually figure out what lambda is. If t is -3, you got to stick that in for lambda. I'm going to choose to put it into this one because it's easiest because lambda's already solved on that other side. And I'll get -1 plus -3 is lambda is -4. If t is -3 but lambda is -4, what does that tell you about the time that they reach that magical point? They cross, but at different times, yes. One of them crosses at -4. That's like these two vectors where, again, if I backed them up, they would both end up touching back here at negative time. But if I just let them go forward with positive numbers, they would never touch. But if I back them up, they would have been in the same spot, but not at the same time. You'd have to back up the one 4 seconds and the other one 3 seconds if the problem's in seconds. All right, so then the really, really important final step, what was that point? How many of you have already got that point? Okay, that's only 4 people. Please, everybody, take a second and find where is that spot that they both touched, but at different times. And by the way, it's the only spot that they both touch. They don't share any other points. They never touched any other spots together. They don't share any other spots, but they both happen to go through that spot. Sir? That's what I think you're getting at here, and this is an important point, is if I had just solved the top 2 equations, I should really check that answer I got in the third equation. And I don't think I ever did that, so thank you for reminding me. I should stick this -3 in here, and I should stick this -4 in here and verify that it works. Because sometimes it doesn't, and you're right. That could mean I never checked. I happen to know these cross, but I never checked my third equation, and these might not actually cross. The other way that that would be like shown up right now is these would come out to different points when you stuck them in. You should have been sticking in a -3 right here, and you should have been sticking in a -4 right there. I know it involves 7. What did you get?
I got -7, -4, -5.
Raise your hand if you got -7, -4, -5. Okay, awesome. That's the spot they both share. Okay. That's about the hardest that they get. So we did the angle between two. Here's a simple one that's just like really important, and I haven't reviewed it, but I feel like I better. I hope this is simple, but if I start at 715 and I go to 8, -2, 9, can you write a vector for that if it goes from this point to that point? It's a crucial skill because that comes up in word problems, because they can be like, well, the train started at this location. Actually, it probably wouldn't be a train if it's 3D. We'll say plane. Plane started at this location and ended at that location. Or in the context of our thunderstorm, flash to bang, we talked about before the video started, the lightning bolt starts at 715 and ends at 8-29. Do you know lightning bolts have so much power that like a lightning bolt could like run a Minneapolis for like an hour? Just one lightning bolt that could be like power the whole city. So if you have a lightning storm that has a whole bunch of lightning strikes, if you could somehow harness that energy, it's not that hard to attract a lightning strike, by the way. You just have to put something really high up, have it be metal, and it's likely to be every time a storm goes by, it's likely to get hit. So they have special things on really tall metal stuff to absorb lightning strikes and make sure that it doesn't destroy the thing. Okay? But if one of you are our future, could just figure out a way to store that energy. That doesn't seem that hard because I can make lightning hit something for you. It's easy. Really tall metal pole. Done. Storms are going to come over. If one of you could figure that out, it would be $1 billion idea. Billion with a B. You'll be the next Mark Zuckerberg. That's part of the problem. You need something to store it in. Yeah. True, you can't have consistent like lightning bolts, but again, store. I said store, not like use. But if you could store it, if you could use that to somehow just store it in a battery, because then you could run off the battery for the next 3 days until another storm comes over. Know what I mean? Yes. Couldn't you have what? Ooh, interesting. Yeah. Telescoping things that like raise their little metal probe thing way up into the sky. Yeah, absolutely. I like that. And I'm sure there's certain places where they get tons of thunderstorms too, and you'd probably plant a bunch of there, kind of like you do with wind turbines, right? So, if one of you guys can figure that out, instant billionaire, guarantee it. You figure it out, and then you've got to make sure that you don't get robbed when you tell the power plant company, like, hey, here's how you do it. And then they go, great idea, we're going to do that and patent it. Yeah, you got to get a patent on your idea. And that's not cheap. From what I found, like the minimum end of it, unless you're a lawyer and can do all the work yourself, probably like $15,000 to get a patent on something. But really, if you have the idea, would you pay $15,000 to patent $1 billion idea? Yeah, that would be no big deal. You could, pull a mortgage on your house or borrow some from a friend and say, tell you what, give you 1% of it if it goes big. You pay for the patent. A lot of people have done that, like the guy who took a bet on Zuckerberg's business. He's the guy who invented Napster. And he saw this Facebook thing as that could go big, so he invested in it. He became a multi-billionaire from being just an investor in Facebook. Never even had the idea, just like gave him $1 million or something out of his multi-millions he'd made from Napster. He was an investor. Yes. Oh. Yeah, it really wouldn't have been that hard. I could have been an Apple millionaire very easily. It's just like so painful because it doesn't seem that long ago. I own 22,000 shares of Apple. And right now Apple shares are worth about, and by the way, back then they hadn't split yet. So then you have to take whatever Apple's share price is right now and times it by 7. And that's how many shares, that's about $700 a share and 22,000 shares. So that's a lot. But I made a profit on it, and I sold it because I thought, oh, nobody knows something's going to go up that much. You just don't, nobody can predict that future. So, I had 22,000 shares of Apple.
They were $700 each.
And because that'd be $15.4 million, yes. There you go. All right. So, you know, if you invest long enough, you'll have plenty of stories like that. Oh, I could have, because there's something happening right now today that you could probably do that would be like that, and you'll look back and go, oh my gosh, I could have. There's other things that you could have, like I bought one where it was Bear Stearns. Ever heard of that one? The first one that went out of business in 2008, started that financial crisis thing. I owned it like 6 months before it went out of business. It went down a little bit. I got nervous. I got out. I had it at like $50 a share. It went to zero very quickly. So stocks can also do that. You can lose everything that you had in it. I bought some Arch Coal recently, and Arch Coal was a company that was down to about $1 a share, and George Soros bought a ton of it. And I thought, ooh, Soros is really smart. I'll do the same thing as Soros. So I bought it. It went up a lot right away. Dang, I wish I would have sold it. Because then within 3 months, it went out of business. Filed for bankruptcy. So there goes, I think that was about $7,000. Boop, gone. Poof. Yep. So that's the downside. People will always tell you about their, I'll be willing to share both with you. People will always tell you about, I was really smart and I bought this and it went up. I'll tell you the other side of it is, they don't always go up. If they always went up, everybody'd do it and everybody'd be millionaires. Yes? You can bet against the market. So if you think, for instance, that the Apple, for instance, is about to go down. There was a guy who made that bet. His name is Doug Cass. He's he's an investor. He's like an advisor to people, and people pay money to get his advice. And he made a good call on that one. He said short Apple, and he shorted it himself. And it went down from, Apple was at about $130 a share, and it went all the way down to like $90 a share. So then instead of it going down and you losing money, when you short it, you actually make money for all the down is actually up for you. So, all right. I haven't, but I want to, and I do know. Yeah. All right. So, Mr. TN, tell me, well, abbreviated or nickname. Go ahead. This answer for this question that goes from that to that. XYZ turns into, do you have it yet? Maybe you were correct. Yes. That is a 9. Raise your hand if you had the same thing. Awesome. All right. Then we've done angle between two vectors. We've done make a vector parallel to this. We've done make a vector perpendicular to this. We've done would this vector intersect with this. Have we done unit vector yet? Okay. And then using the unit vector to make a vector any length you want. All right. So I think then I can just kind of ask a few more kind of fun real world things. In what ways do you think sound could be a vector? Like we talked about, lightning bolts has the light comes to you, and the lightning bolt itself goes from this spot to this spot on the ground or tree or whatever it hits. So there is air-to-air lightning, cloud-to-cloud lightning, but yes. Ooh. He said arguably it could be the zero vector because sound goes in all directions. Just think about how annoying it would be if you had to have the sound directed directly at you to be able to hear it. A sound beam, cool. Oh, that's cool. So they could hear it, but nobody around them could. That could make awesome practical jokes. Because people will be like, "Didn't you just hear that?" And they'll be like, "No." If you could direct it just to them, that'd be awesome. Yes, sir. Ah. I have heard of actually using sound. I don't know about the whole directed at, I suppose they can direct it at a bunch of people instead of just at one person. But yeah, they can direct an incredibly loud noise at you, It's kind of like spraying a hose on you. It doesn't kill you. It just really annoys you, makes you want to run away. Cool. So that would be a great example of a sound vector. Love it. All right. And that's all I got for the video for today.